everyone. In this video, we are going to explore the microcontrollers and IoT subject. In that Unit 5, we are going to discuss in that IoT in Smart Health. Let's recall the last class topic. In last class, we have discussed about the Internet of Things fundamentals and architecture. In that, we deeply discussed about the IoT definition and concept, IoT architectures with different application layers, enabling technologies, IoT characteristics and trends, and MQTT protocol for IoT specific applications. So today's topics for discussion, we will start with the transforming health with personal devices in IoT and the Internet of Medical Things, that is IOMT, and essential medical sensor requirements, securing patient data in IOMT systems, solutions for robust data security, simulating a heart rate monitor, that is ECG, SpO2. And we know that a smart health designing wearable IOMT for a healthier future. So we know that the IoT market is rapidly projected in $187 billion by 2028. So this focus is on wearing health monitors for ECG and SpO2. So these devices give enhanced preventive care and remote patient monitoring. So we address chronic disease, reduce cost and improve healthcare access for everyone. So now let's move on to the design thinking phases with IoT in smart health. So the first stage is empathy stage of design thinking, that is transforming health with personal devices. So we know that devices like the Apple Watch ECG have made a huge impact since 2018. With FDA clearance, it can detect arrhythmias and even identify atrial fibrillation in thousands of users. This marks a shift from reactive care to predictive health monitoring, where users take early action before problem worsen. Now let's move on to the defining stage of the Internet of Medical Things, that is IOMT. So in that it connects the Internet of Medical Things, connects the medical devices and healthcare IT systems through IoT technologies. It collects vital data such as heart rate, oxygen levels and body temperatures, it enabling remote care, telemedicine and market growth in smart hospitals. Globally, IOMT is growing at a 28.9% compound annual rate, showing a massive potential. Next, move on to the defining stage of DT. It is essential medical sensor requirements. The medical sensor requirements, first we see about the accuracy of that. The accuracy of ECG must be 0.5 to 5 millivolt range, and the SpO2 accurate as a plus or minus 2%. And the low latency under 50 milliseconds is vital for real-time alerts, and all data must be AES-256 encrypted for safety purpose. Finally, the system should ensure 99.9% uptime, a robust error handling for continuous monitoring. And the next one is the ideate stage of design thinking. So in the ideate stage, we brainstorm how to protect sensitive health data. Patient information, also known as PHI, must remain secure and complying with laws like HIPAA and GDPR. For instance, if data is sent over public Wi-Fi without encryption, it becomes highly vulnerable, so strong protection is essential. And the solution for robust data security is, first one is a ideate stage. In that, the first solution is a encryption. The strengthened data security, we can use end-to-end encryption between devices and cloud. So secure hardware modules for key storages and multi-factor authentication to control access. Regular penetration testing ensures vulnerabilities are quickly identified and fixed. Maintaining patient trust and system reliability is the important and foremost one. So next, move on to the prototype stage of the design thinking. So in this prototype stage, we can simulate a wearable IOMT devices using MAX 30100R102 pulse sensor within ESP32 microcontroller on Tinkercad circuits. We can virtually connect the setup to read pulse rate and oxygen saturation and display the results on a serial monitor. This simple prototype demonstrates the how IoT enables real-time health monitoring. And the next one is debugging a privacy law or debugging a privacy law in data flow. In this, it is a critical law. Patient IDs were transmitted as a clear text in API calls. This poses a significant privacy risk also. So to fix this, we can use tokenization or pseudonymization and encrypt identifiers at the device level. This ensures anonymity and compliances with privacy regulations. Next, move on to the future scope of wearable IOMT devices. The first one is will expand beyond ECG and SpO2 sensors. We can expect non-invasive glucose monitoring, real-time blood pressure tracking, and AI-powered predictive analytics of early disease detection. Integration with electronic health records, that is EHR, will make healthcare more personalized and seamless one. Now let's move on to the conclusion part of mind map and conclusion part of this video. The mind map includes the wearable IOMT for smart health. This gives the IOMT definition and scope, essential sensor requirements, prototyping and simulation, data security, and impact of future scope. Now let's move on to the assessment stage. That is, wearable health devices are used to monitor temperature only, heart rate, SpO2 and activity levels, weather conditions, internet traffic. The answer is heart rate, SpO2 and activity levels. IOMT stands for, we know that it is the Internet of Medical Things, Internet of Mobile Technology, Integrated Online Medical Transmission, Intelligent Operating Medical Tools. The answer is Internet of Medical Things. So summary of this presentation is a wearable IOMT empowering proactive health. It gives the revolutionizing healthcare, rigorous design and crucial prototyping. The prototyping and debugging are vital for effective solutions in IoT. It includes the microcontrollers in IoT. These are the references for this topic. Thank you.